Today we're starting Chapter 4. So you want to have your Chapter 4 notes packet starting on page 1. We'll be covering pages 1, 2, and 3 today. Relations and functions. You have worked with functions before in Algebra 1, so hopefully some of this will be review for you. Other things will be new. So first term, a relation. A relation is a set of ordered pairs. A relation can consist of numbers or other items and may be represented as a list, table, graph, or mapping diagram. Here are some examples of relations. You have relation A, which is defined as a set of ordered pairs April 1, June 7, November 25. Relation B is a set of ordered pairs 2, -3, 4, 8, -5, 5, -11, -3. Relation C is this mapping. This is saying that the number 2 goes to prime, 13 to prime, 9 to perfect square, and 5 to prime. And relation D, which is an actual graph. And back from Chapter 5, this looks like it represents the graph of a cubic equation, right? A polynomial equation of degree 3. Now, the domain of a relation is a set of first or independent elements, and the range of a relation is a set of second or dependent elements. It's very important that you know domain and range. List the domain and ranges of the relations above by completing the table below. So for relation A, our domain is a set of first elements, April, June, November. And our range is a set of second elements, 1, 7, 25. For relation B, our domain is the first elements, 2, 4, -5, -11. And our range, -3, 8, 5, -3. Now the -3 need not be written twice, so actually I'm going to just change that into the end of my set notation. Relation C, our input or our first elements, 2, 13, 9, and 5. Our output or our second elements, prime, perfect square. And relation D, our domain would be our x values, all right? Now this continues to go downward and outward to the right, and upward and outward to the right. Sorry, that was downward and outward to the left, and upward and outward to the right. So for this, our domain is going to be all real numbers. And we would write this as the set of x's such that x is an element of the real numbers. And the symbol for real numbers is, I'm going to write it off here on the side. It's a capital R with an extra vertical segment, right? And our range is a set of all real numbers. So I think for this is I'll just write all real numbers. All real numbers is denoted by a capital R with an extra vertical segment written. Notice that the number of elements in a domain and range are not necessarily equal, and element appearing twice in a domain or range is listed only once. In 1 through 6, each graph shows a relation on a set of coordinate axes. State the domain and the range of each relation. When you're looking at a graph, on a graph, the domain is your x's. So you're looking at your leftmost point to rightmost point. This is very important to remember. Leftmost point to rightmost point. PT for point. And when you're looking for the range, your range is your set of y's. And that would be your lowest point to highest point. And sometimes there might be breaks in between the lowest and highest point. All right, so for a domain, leftmost to rightmost. Here's my leftmost point, and please take your hands, all right, and place it at the leftmost point. And then take your other hand, place it on the rightmost point, all right? So this is my domain. What does our domain go from? From -4 to +5. But there's a hole in between, right here at +2. Remember, I'm looking at my x value, so I'm looking at my x scale. From -4 to +2, but there's a hole at +2, and then from +2 to 5. So I would write this as, I'm going to use interval notation. Parentheses, -4, comma, 2, parentheses, union with 2, parentheses 2, comma 5, and a bracket around the 5. Now, that's interval notation. Now, for the range is the lowest point to the highest point, okay? So lowest point is right down here. Highest point is up. What's the y values here? Let's see, our lowest point, our y value is -2, and our highest point, our y value is +5. Are there any holes between there? Well, there is one here at 4, but it's also solid at 2 other places. All right, so we're going from -2 to +5. That's a closed -2, so bracket -2, and the +5 is open, parentheses at +5. And we'll come back to the function in one-to-one questions part of this. Go to number 2. We want the domain and the range. Again, the domain is the leftmost to rightmost. Okay, leftmost point is here at -3, but this continues. There's an arrow on it. So it continues upward and outward to the left. So it keeps going way out to the left. What's way out to the left? -infinity. And the rightmost point, 3, but again, there's an arrow. So this continues going outward and upward to the right. And what's way off to the right? Keep going. +infinity. So our domain we can express as -infinity to +infinity. Or it can be written as all real numbers. I could write the words or the symbol for all real numbers. Now our range is our lowest point to highest point. Okay, my lowest point is right here, right? -4. And then our highest point, well, up here at 6 there, but it keeps going all the way up. Keep going up, 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 up. Where are we going to? Infinity. So our range is from -4 to infinity. Or we can write it as the symbolic form, y is greater than or equal to 4. Sorry, -4. Y is greater than or equal to -4. Next page. Still practicing with domain and range. Domain for this graph, right? Domain, remember, is your x's. Think of your x's. D comes before R in the alphabet, so domain is for x's, range is for y values. Domain, leftmost to rightmost. Here we go, right here. What are my values for x? -2, 4. No holes in between. So interval notation, parentheses, -2, comma 4. Oops, sorry, that's 5. Thank you. -2, comma 5. Or symbolically, all right, we can write this as x is going from -2 to 5. So -2 less than x less than 5. Our range, lowest to highest. Lowest point right here, what's the y value? -4. Highest, +5. So that's -4 to +5. Oops. All right, I have to go back and correct my domain, right? It was +4. I think I started off with 4, but then I don't know. I guess I should be wearing my glasses. Sorry. All right, and our range symbolically -4 less than y less than 5. And let me correct my symbolic form for my x's. That's supposed to be a 4. Next, number 4, our domain. Leftmost to rightmost. Okay, leftmost point here at 5, -5. Rightmost point here at 4. No holes in between. There is that hole up there, but it's covered over here. So our domain would be bracket -5 to parenthesis 4. And our range, lowest to highest, lowest point -3, highest point 4, open at -3, so parentheses -3, comma 4, parentheses. Now 5 and 6 will start off together in class tomorrow. Going on to page 3. Functions, right? Functions are rules that assign exactly one y value to each value of x. Not every equation is a function. You may be asked to recognize a function from its equation or from a graph. From an equation, look for y. If there is no y in the equation, it is the equation of a vertical line, meaning it's an x equals something. X equals some constant, c. These are not functions. Is y squared? When y is squared, the equation has two possible y values for some values of x. These are not functions. So if there's no y in the equation, it's not a function. If y is squared, it's not a function. If y is there and it's not squared, the equation is the equation of a function. So from a graph, okay, the vertical line test, we draw vertical lines on the graph line or curve. If each vertical line intersects a graph line or curve at only one point, then it is a function. In other words, if there is more than one point of intersection, then it is not a function. We'll also note later on that there's a horizontal line test that can be used to determine if a function is one-to-one. That'll be more about that later. Okay, so which of the following are functions? We have an equation where there is a y, and just a y, so this is a function. Just circle it. X equals 15, there's no y there, this is not a function. We have y squared equals x plus 2 because of the y squared, not a function. Y equals 2x squared minus 3x plus 6. There's a y there, it's not squared, so this is a function. Remember, if there's a y and it's not squared, it's a function. For these diagrams here, all right, we would draw vertical lines. And if a vertical line crosses a graph in more than one spot, like this does, this is not a function. Take the next figure, drawing vertical lines. And it's hitting the graphed figure at more than one point, so it's not a function. Draw vertical lines here. Each vertical line crosses the graph at only one point, no more than one, so yes, this is a function. And this guy is a function. And here, drawing vertical lines, each vertical line hits the graph at only one point, so it is a function. Alright, so this will conclude our video for today, and tomorrow in class we'll go back to page 2 and fill in the domain and range for numbers 5 and 6, and then we'll also go back to page 1 and 2 and fill in whether or not the graphs are functions.